cosmic abyss is a pitch-black, endless void, yet hidden within this darkness are ghost worlds burning with a silent, secret fire. Some planets don't need a star to survive. The freezing emptiness between solar systems, terrifying alien worlds drift completely alone, untethered, unlit, and cast out into the eternal night. These are rogue planets, cosmic outcasts thrown into the freezing wilderness by violent gravitational chaos or born in the pitch-black cold. Today, we return to this mind-bending mystery with revolutionary new insights. We once dismissed these phantom worlds as mere cosmic anomalies or doomsday threats, but everything has changed. Mind-blowing new discoveries reveal they are everywhere, forcing us to rethink how life could survive in the dark and how humanity might actually build colonies on them. In this video, we explore how we could conquer the most extreme frontiers in the universe, and these rogue planets might be the ultimate test. Imagine a world with no sunrises, no seasons, and absolute darkness. Only a frozen sky above, where heat is the ultimate currency and atmospheric pressure means survival. Out here, staying alive isn't about breathing air. It's about shielding ourselves from the lethal vacuum and generating enough power to keep our blood pumping. Yet, even in this terrifying abyss, hope survives. Beneath miles of ice, hidden oceans could be warmed by raging geothermal fires, insulated by thick atmospheres of exotic gases. Some massive giants even harbor their own moons, harboring secret ecosystems locked under frozen crusts. Armed with fusion energy, colossal megastructures, and sheer human defiance, we wouldn't just survive on these lonely giants, we could conquer them. So, what actually is a rogue planet? How many of these dark wanderers are lurking in the shadows? And what would it take to build a human civilization on one? Let's dive into this uncharted territory. Rogue planets, also known as cosmic nomads, are massive worlds hurtling through the deep void, completely freed from the gravitational grip of any star. With no orbit to bind them, they drift aimlessly through the galaxy, dragged along by the massive gravitational tides of the Milky Way and passing cosmic clouds. These aren't just tiny chunks of space ice. They are fully formed worlds, ranging from frozen rocky spheres to massive gas giants and failed stars, many harboring their own moons. While they seem like rare cosmic accidents, shocking new data suggests they are incredibly common. Early theories predicted only a few rogue planets per 100 stars, but revolutionary microlensing surveys like OGLE and MOA suggest a staggering reality. There could be up to 200 rogue worlds for every single star. This means trillions of phantom planets are drifting through our galaxy, vastly outnumbering the stars themselves. The smaller they are, the more common they become, meaning the dark void is absolutely teeming with Earth-sized and Mars-sized worlds waiting to be discovered. Far from being rare anomalies, these cosmic ghosts might actually dominate our galaxy, shrouded in pitch-black silence, waiting in the shadows. But how does a world become a rogue? Some are born into the dark. During the violent birth of solar systems, massive clouds of gas and dust collapse before a star can even ignite. In these chaotic stellar nurseries, some newborn worlds are denied a parent star entirely. Instead, they freeze into giant, sunless wanderers cast out into the void before their local stars even stabilize. Others are tragic exiles banished by extreme cosmic violence. In infant solar systems, absolute chaos reigns. Colossal planets wage gravitational war, violently shoving rivals into doom-laden orbits. Experts believe a monstrous early Jupiter, once double its current size, rampaged through our system, migrating inward before retreating. One gravitational near-miss is all it takes to catapult a planet into the freezing abyss forever. This terrifying process, known as planetary ejection, likely scarred our own cosmic backyard. Shocking models reveal our early solar system, once harbored lost super-Earths and Neptune-like giants, now banished to the dark. Jupiter's destructive rampage disrupted everything, while passing alien stars brushed dangerously close to our borders. Beyond the moons we see today, ancient planets collided in apocalyptic mergers, like the cataclysm that birthed our moon. Others were swallowed whole by the sun or hurled into the deep freeze of interstellar space. It was a brutal cosmic purge. Interstellar close encounters add to the danger. A rogue star, a dead brown dwarf, or even another drifting planet can sneak close enough to tear a world from its orbit. While rare today, over billions of years, these near misses add up. In fact, a neighboring star breached our outer defenses just 70,000 years ago, and the star Gliese 710 is on a collision course to pass within a mere 22 light days of us. Consider this: Earth is 40,000 times older than the gap between those two flybys. We have survived countless terrifyingly close calls, especially when our galaxy was younger and actively devouring smaller galaxies. The Milky Way is a crowded, hostile place, and planetary orbits are never permanent. Exile can also stem from the chaotic gravity of double-star systems or a slow, agonizing cosmic tug-of-war. These relentless gravitational forces slowly warp orbits over eons until a planet gains just enough speed to snap its leash. It is a slow-motion catastrophe inevitable for crowded planetary systems. Most stars begin life packed in dense clusters that slowly drift apart after planets have already formed. When a world is kicked into the abyss, it doesn't die, it just becomes incredibly lonely. Yet isolation does not mean death. These orphan worlds still harbor massive energy, raw materials, and geothermal heat. The largest may hide thick atmospheres, subsurface oceans, or captive moons. Ultimately, they might even serve as stepping stones for humanity to colonize the deep cosmos. This cosmic stepping stone is our ultimate target today. Tiny frozen dwarf planets could become the ultimate launch pads to conquer massive star systems. But while we dream of seeding these dead, icy worlds, a shocking truth remains: alien life might already thrive there. Next, we will uncover the extreme conditions that spark life on a rogue planet and reveal the bizarre alien ecosystems lurking in the eternal dark. Life in the abyss, rogue planet biospheres. At first glance, a rogue planet seems like a frozen tomb, the absolute last place life could ever survive. Hurtling through the freezing interstellar void, it gets zero starlight, absolutely no warmth from a sun, and only deadly cosmic radiation to pierce the pitch-black sky. Its surface is a hellish wasteland hundreds of degrees below zero, where the very air, nitrogen, and oxygen freezes solid into deadly snow. Exotic oceans of liquid hydrogen and helium might even pool across the landscape. But penetrate the icy crust, and a shocking transformation begins. Consider the mind-bending possibilities of ultra-cold biology like ammonia-based life forms. These bizarre organisms wouldn't even need warmth to conquer the dark. The ultimate candidate for hosting life is the Steppenwolf planet, named for its solitary predatory wanderings through the deep cosmos. These are massive Earth-sized behemoths with colossal ice shells trapping hidden, boiling oceans heated by raging geothermal energy. Right here on Earth, life thrives around toxic hydrothermal vents deep in the abyss, completely starved of sunlight. This is likely where all earthly life began. This exact alien ecosystem could explode into existence on a rogue world, fueled by intense radioactive decay, primordial core heat, or the crushing tidal forces of captured moons. Astonishingly, even 4.5 billion years after its birth, Earth's core remains hotter than the very surface of the Sun. Even without radioactive decay or tidal forces, a planet can trap blistering heat in its depths for billions of years. This is especially true for massive worlds, which generate colossal heat during formation, as intense gravity pulls incoming matter inward, crashing it together with terrifying high-energy force. Fascinatingly, classic speculative fiction like the legendary Deathgate cycle has long imagined these bizarre, gravity-defying environments. They depict mind-bending worlds, from colossal Dyson spheres to hollow planets teeming with hidden subterranean life. In these stories, we witness a world where civilizations survive inside the tunnels of a planet-sized rock. While the surface is a frozen wasteland, the core is heated by glowing magma seas, allowing populations to farm and thrive in massive subterranean caverns. These concepts envision worlds with floating continents, and others with asteroid-sized islands drifting through a global ocean. This closely mimics the subsurface seas we expect to discover on rogue planets, or even on their wandering moons. These wild ideas are no longer just fantasy. Modern science suggests they might actually exist in the dark. Looking back at the moons of rogue planets, we see parallels in our own solar system. Icy worlds like Europa and Enceladus are prime targets for alien life, kept warm by these exact tidal forces. A rogue Earth-sized planet would simply be a colossal version of this, boasting massive geothermal warmth and a thick blanket of ice and gas to trap it forever. Unlike Europa, this world could trap a massive atmosphere. By locking in light gases like hydrogen and helium, it creates a colossal thermal blanket, keeping liquid oceans warm and alive beneath the ice. With enough mass to hold on to hydrogen, a rogue planet becomes a super-insulated greenhouse. It traps geothermal heat far better than Earth's atmosphere, melting the ice deep down and unleashing hidden warmth. Scientists suspect these dark worlds could harbor bizarre organisms adapted to pitch-black darkness, thriving solely on faint infrared radiation. As geothermal energy erupts through icy fissures, it feeds alien bacteria. Instead of sunlight, this life relies on pure chemical power, utilizing chemosynthesis to survive the abyss. Shockingly, Earth's very first organisms might have used this exact same survival strategy. This life would be slow, incredibly tough, and hidden microscopic survivors rather than bustling forests. Yet, it would represent an independent evolutionary miracle, billions of years in the making. Imagine rogue gas giants dragging captured moons through the void, forming their own mini-solar systems. Violent tidal forces, active tectonics, and intense magnetic fields could superheat these moons, mimicking Jupiter's chaotic system. With water, organic chemistry, and internal heat, it wouldn't matter that they are billions of miles from any star. Biology in the pitch black would get incredibly strange, but it is absolutely possible. Organisms might swim in sub-zero ammonia slush or navigate oceans of liquid hydrogen. These are extreme alien worlds where our laws of biology are completely shattered. While this exotic chemistry sounds like science fiction, nature proves that life always finds a way, thriving wherever there is energy and stability. And what nature cannot create on its own, human engineering might build from scratch. Future civilizations could engineer custom organisms from scratch to populate these frozen worlds. Beyond basic survival, we could see the creation of massive synthetic beasts designed to navigate oceans of liquid helium. Such engineered creatures could completely redefine how humanity interacts with these extreme environments. Instead of just adapting humans, entire ecosystems could be tailored for the dark. Extremophile crops, deep-burrowing organisms, and glowing lichen forests thriving in the cracks of alien stone. While search efforts focus on Earth-like planets in traditional habitable zones, simply because biosignatures are easier to spot there, rogue planets drifting in the deep void might actually be the ultimate places to look for alien life. These worlds are quiet, frozen, and shielded from the violent stellar flares that ravage normal solar systems. If life has taken root here, colonization won't just mean building survival bunkers, it will mean sharing a home with ancient alien organisms. Yet, even if these worlds are completely dead, they are far from useless. They offer a treasure trove of raw materials and protected environments, providing the perfect foundation to build interstellar civilizations from scratch in the deep void. Next, we dive into the mind-blowing habitats we could construct on these dark worlds, from colossal cities buried deep beneath the ice, to floating colonies drifting on bizarre seas of liquid hydrogen and helium. Welcome to the ultimate challenge, colonizing rogue planets. The first terrifying obstacle, crushing darkness. Zero sunlight, no day-night cycles, and absolutely no warmth from a parent star. But that doesn't mean we have no options. No light, no problem. Armed with fusion power and determination, we will conquer the void. A rogue planet's surface is a frozen wasteland of lethal cold, but beneath that icy crust, geothermal heat still rages. With cutting-edge technology and powerful fusion reactors, we won't just survive in cramped bunkers, we will thrive. We can build massive, bustling civilizations hidden under the ice or floating on alien oceans. These rogue planets are incredibly common, scattered by the billions. They will become critical stepping stones across the cosmos, hosting massive populations. A galactic empire could rise from these frozen depths, climbing the Kardashev scale from deep below the surface. Yet reaching them depends on mastering the smallest details. Even stepping onto the surface could be deadly if your boots aren't engineered right. Hundreds of degrees hotter than the frozen gases beneath you, they could cause the ground to erupt. In environments like that, every system, from airlocks to bootlaces, demands absolute precision. While mastering these extreme engineering challenges remains a distant goal, the quest for survival drives us to explore the most viable habitats first. Let's look at the most obvious solution: digging deep. On many rogue worlds, especially Steppenwolf-class planets, the surface is locked in a permanent, deadly freeze. But deep beneath that frozen shield lies a hidden sanctuary of warmth, heated by geothermal activity and the planet's own primordial core. Harnessing that extreme thermal energy lets us carve out massive underground strongholds deep inside frozen worlds. This colossal shield of ice blocks the deadly vacuum of space while perfectly masking our thermal footprint from hostile alien eyes. Humanity is on the absolute verge of mass-producing indestructible materials like graphene and diamond for megascale construction. Imagine massive diamond domes shielding entire civilizations. Using cheap, abundant carbon, we could soon build sprawling cities buried dozens of miles beneath frozen oceans. These subterranean fortresses offer endless energy, limitless minerals, and the ultimate defense, a perfect, impenetrable bunker hidden from cosmic threats. Picture Outer Rim ice worlds transformed into heavily armed military outposts. Just like medieval castles, these bases cannot be ignored. Any invading fleet that dares bypass them risks being utterly annihilated from behind as hidden warships launch from subterranean bunkers. In the brutal physics of space combat, a pursuing warship holds a devastating advantage over fleeing prey. Because of this, every massive space rock will become a militarized outpost. But rogue planets remain the ultimate prize, hosting massive cities, thriving economies, and colossal fleets. Think of colossal vault cities buried miles deep, shielded from deadly radiation, where artificial suns illuminate massive hubs powered by roaring fusion reactors. Towering vertical farms will cultivate genetically engineered crops, warmed by the excess heat of nearby power grids. In these dark, humid depths, massive mushroom plantations will dominate food production, thriving on geothermal heat. Many colonies will cling to volcanic hotspots or nestle deep beneath frozen seas to harness natural planetary warmth. Others will use advanced thermal drilling to slowly melt and expand their tunnel networks over time. It will start as a claustrophobic struggle for survival, but will eventually evolve into breathtaking, futuristic metropolises. Picture glowing crystal caves, bioluminescent forests, and massive O'Neill cylinders suspended in low-gravity ice chambers. Inhabitants will float effortlessly through interconnected transit tubes, linking entire subterranean worlds. These are not mere survival shelters. They are vibrant cultural havens filled with art, life, and grand architecture, thriving deep inside dead planets. Imagine floating cities drifting on oceans of liquid gas. Under extreme atmospheric pressures, bizarre oceans of liquid helium and hydrogen cover the surface of these alien worlds. This sounds like science fiction, but it is entirely real. Massive rogue planets and super-Earths can trap enough heat to keep these alien oceans liquid. Conquering these extreme environments will be our greatest challenge and our ultimate triumph. Imagine colossal city ships, resembling monstrous Arctic oil rigs, drifting precariously on a lethal ocean of liquid hydrogen at a mind-numbing 20 degrees above absolute zero. To survive this extreme deep freeze, their massive hulls must be forged from revolutionary layered metamaterials and ultra-resilient carbon composites that will never shatter. Inside these massive domes, humans breathe easy, but outside lies a deadly frost-coated wasteland, demanding constant vigilance against catastrophic atmospheric leaks and structural collapse. Though water is abundant across the cosmos, even if trapped as deep ice beneath helium seas, any oxygen escaping the habitat's cracks would instantly react with the surrounding hydrogen, threatening the colony's very survival. These sci-fi metropolises could levitate just above the surface using powerful magnetic propulsion, advanced superconducting skates, or self-healing rafts engineered to float on the bizarre alien cryofluid below. Fortunately, we already possess cutting-edge superconductors that operate effortlessly at these extreme ultra-cold temperatures and even much higher. Because liquid helium and hydrogen are incredibly light compared to water, floating on them is a massive challenge. These vessels must be engineered with ultra-low densities, far lighter than any submarine or ship we have ever built on Earth. Thankfully, sheer size is the ultimate savior here. A massive dome filled with air can easily float on these alien seas, even with heavy, meter-thick protective walls shielding lush, landscaped ecosystems, soil, and running water inside. These colonies could devour the surrounding ocean for fuel, harvesting deuterium and helium-3 to power next-generation fusion reactors. Alternatively, they could use the freezing sea as a giant insulating buffer, keeping the habitat warm while extracting power from deep-core fission reactors or other advanced energy sources. Living here would feel far more alien than any lunar base. Beneath a pitch-black sky, on a sea shimmering like frozen mercury, these glowing cities would shine like warm beacons in an eternal winter. Just as we dream of floating cities on Venus, these rogue world flotillas represent the ultimate defiance, proving that even in the coldest corners of the cosmos, life can float. But how do we expand across this frozen frontier? A colony might start as a single underground bunker, a floating city, or even an orbital station linked by a space elevator. Yet human curiosity, growth, and the need for survival will inevitably force us to expand, pushing our boundaries further into the dark. Surprisingly, despite the brutal cold and darkness, these rogue worlds offer unmatched geological stability. With no shifting seasons, minimal tectonic activity, and zero threat from solar radiation storms, our infrastructure could endure for centuries if built correctly. Free from the tidal pull of a nearby sun or moon, seismic activity fades over time, stabilizing the ground and making it the perfect environment to carve out massive, permanent underground megastructures. Early surface travel will be slow and perilous, restricted to autonomous robotic drones and heavily shielded transports navigating preheated tunnels or rail corridors carved deep into the ice. High-speed maglev trains, supercooled superconducting conduits, and heavily armored freight crawlers will move people and goods between these isolated outposts. On massive rogue planets, we could build planetary-scale rail networks, creating vibrant arteries of civilization across a world that is otherwise silent and still. On smaller worlds, we could drill colossal shafts straight into their molten cores, unlocking unimaginable power and infinite mineral wealth. Energy would pulse through these artificial veins like liquid fire. Picture a massive interconnected network, beaming raw energy from colossal fusion reactors to distant outposts through superconducting cables buried deep under frozen rock. Every drop of waste heat is recycled to keep biodomes alive, acting like a mechanical circulatory system. Alternatively, isolated outposts could survive entirely on their own, harvesting local ice, mining deuterium, and extracting life-saving oxygen from frozen carbon dioxide. A rogue planet looks dead from space, but deep underground it could be screaming with life. Think thriving hidden cities, genetically engineered biomes, fanatical cults, or lawless pirate havens hiding in the shadows of the cosmos. And if these phantom worlds are as common as scientists now believe, we are looking at a massive hidden cosmic highway. Some will host sprawling colonies, others will serve as high-tech fuel depots, secret military bases, or vaults of lost knowledge. Navigating this pitch-black abyss is terrifying, but compared to crossing the empty void between stars, these rogue planets are stepping stones, lonely islands in a dark ocean. Over generations, this network could become the ultimate highway for slow-motion interstellar conquest, a process of colonizing the dark when warp drive is out of reach. Instead of leaping between distant suns, humanity will conquer the galaxy one shadow world at a time. We won't just colonize the light, we will master the absolute dark. Out of the shadows, a new empire rises in the void. Rogue planets are eerie, silent, and completely isolated. There are no sunrises here, only the cold starlight and the constant haunting hum of life support machines. Yet that is exactly why they draw us in. They are pitch black, but bursting with hope. They could become the ultimate sanctuaries, monasteries of the future, far from the chaos of the galaxy. Or they could be unbreakable fortresses built to survive cosmic apocalypse and preserve humanity for eternity. Perhaps they are both. These aren't just forgotten outposts, they are the backbone of human civilization. Rugged, self-reliant, and strategically vital. They will host colossal laser arrays, launching starships to near-light speed and catching them as they arrive, shattering the limits of rocket physics. These massive lasers will be fueled by endless oceans of hydrogen locked in the ice. A civilization that conquers these rogue worlds won't just survive in the dark, it will dominate the most hostile corners of the universe. Generations will grow up under artificial skies, never knowing a real sun. Their myths will speak of stars the way we speak of lost utopias. And when they finally launch into the deep, they won't be fragile explorers, they will be battle-hardened pioneers, masters of the dark, bringing light to a cold universe. The torchbearers of humanity. But remember, these frozen worlds are not just waiting for us. They might already be occupied. Life doesn't need comfort. It only demands time, energy, and relentless adaptation. And these rogue planets offer all three, hidden in the deep dark. If ancient alien minds or forgotten worlds are hiding in the freezing cosmic abyss, we are looking in the wrong place. Forget the bright stars, the ultimate secrets lurk in the terrifying pitch-black voids drifting between them. These rogue planets prove the cosmos is a hostile wasteland, but humanity has never backed down from a challenge. We will conquer the abyss, ignite our own destiny, and carve our legacy into the eternal darkness.